So, as I always say, it's best to get an estimate. For the numerator, the plus 5 doesn't really contribute much, so what we're comparing is n squared to 5 over n. As far as classes of functions go, polynomials are pretty weak. They do go to infinity, but they don't do it very fast. So if we were to compare the function n squared, or the polynomial x squared, the plus 5 doesn't really contribute that much, so just look at x squared. Compare that to 5 to the x, and let's see, 0 to 10 should be fine, and then it's not going to be negative, so 0 to 10. I think if I put 10 for x, 10 squared is 100, so this thing, and now it's going to be even bigger, 100, maybe 200. Let's see. So there they go. This is the exponential function. It already took off and went to infinity. This is on its way to infinity, but it's just like going to infinity. And that is the parabola. So this is a pretty weak function compared to this one that goes vroom, rocket just takes off. So my point is, you basically got a number divided by a huge number. The result is going to be very small. So my guess is that it's going to converge. Now we could look and see, what do we want to use? What's on the menu today? Well, we could do the ratio test, where you substitute an n plus 1 and you substitute an n and divide them. I think that would be a good idea, because if you have a 5 to the n plus 1 that gets divided by a 5 to the n, it cancels pretty nicely. Let's try that. So it's a good idea to write down what test you're using so a person reading your work can follow. Use the ratio test, so that means take the limit as n goes to infinity. Technically it's supposed to be the absolute value, but these are positives, so I don't have to do that. Then substitute n plus 1. Then divide by when you substitute an n. Well, if you divide by a fraction, that means invert and multiply, so that's going to be 5 to the n for the top, and then n squared plus 5 for the bottom. And then here's what I was promising about this is going to cancel this, leaving just a 5. So then we have the limit as n goes to infinity. The denominator, you can multiply these two, and it's going to be 5 times this will be 5n squared plus 25. And then we need to multiply this out, which is going to be n squared plus 2n plus 1, n squared plus 2n plus, and then 1 plus 5. So the answer is 1/5. So from pre-calculus, you should know, you just look at the most powerful terms, n squares are going to cancel, the answer would be 1/5. We could actually use some calculus and say, well, if this is infinity over infinity, you're allowed to use L'Hopital's rule, which we'll need to do twice. Take the derivative here, it's going to be 2n plus 2. Take the derivative here, is going to be a 10n. This is still infinity over infinity, so you're allowed to use L'Hopital's rule again. So we've got limit as n goes to infinity. The numerator is going to be a 2, the denominator 10, and so it is a 1/5. And the ratio test says if you work out that limit and you get something that's less than 1, then it converges. Less than 1, therefore this series converges.